climatologist. I've been here at the University of Missouri for about a year now. And so this picture I'll start with here is from campus here on the University of Missouri. We have on Sanborn Field some agricultural test plots, and this is one of our Missouri Mesonet stations. And I took this picture on a pretty clear day in late July, and just want to point out that that Mesonet tripod is about 9 feet tall. So you can see how tall that corn was by late July. And I think that might be a common occurrence we're seeing across a lot of the region. And so before we get started today, I did want to say that today's and past recorded presentations as well are always available through these two links, either the Midwestern Regional Climate Center or the High Plains Regional Climate Center. And also these webinars take place every third Thursday of the month. And so our next webinar is scheduled for Thursday, September 19th, 2024. And that presenter will just be the neighbor to our east. We'll move over one state to Illinois, and it'll be Trent Ford presenting the Illinois State Climatologist. Otherwise, here have some other useful links. A lot of these will contain some of the data and products and tools that are shown today, and then also a couple links for finding and contacting your state climatologist or regional climate center for guidance as well. But what we'll go through today here is start with a look at recent conditions. And so here's a picture from Shelby County, Kentucky on July 25th. Pretty lush agricultural land here. See some pastures in good shape and what looks like some soybeans as well. And if you haven't caught on to the theme yet, starting with a lot of nice landscape pictures, and I think that's because when we go through our recent conditions, it's actually been a relatively calm month here in the north central region. And so we'll go through the recent conditions, talk about some of the weather and climate impacts as well, and then go through outlooks and take a look at what's next. And finally, as Doug mentioned, have some time for a Q&A at the end. And so to get us started, let's take a look at how our statewide temperatures fared in the month of July. And so what this map is showing is the statewide averaged temperature throughout the month, and then ranked according to the historical record here. And so for each state, we have data back to 1895, which covers about 130 years here. So when you see the numbers that are higher and the red or warm colors, those are going to be above average temperatures, and those rankings that are closer to 130 are those highest rankings. So looking across the central region, we don't have a lot of the dark colors. Actually, a lot of our temperatures were really closer to average. The most anomalous across the region was Montana, who experienced their 10th warmest July. But otherwise, the maybe big highlight is if you see the blue in the center of the country here, this is where we did have cooler than average temperatures across the Corn Belt. Not significantly cooler than average, as we see the coolest here is Missouri recording their 32nd coolest July, but still below average. And for a lot of these states, we had put together a consecutive streak of many above average months before July, and so kind of a buster for getting rid of those above average temperatures there. But the main theme, I think, is we didn't set any statewide temperature records during July, and a lot of these pretty close to normal. Now, those were just showing the statewide average temperatures. We can also look at a little bit more closely. This is going to be our county temperatures, but also broken down into maximum and minimum temperatures here. And so we see on the left, a lot of those same locations where we were seeing the statewide below average temperatures. We see that same core of blue color in the middle of the country showing those cooler than average maximum temperature anomalies. But on the right, when we look at the minimum temperatures, we don't see as much blue and really see more of the white color indicating near average. And so this map really helps to determine the flavor of how those below average temperatures looked last month. And this kind of indicates maybe some wetter conditions that were keeping those daytime high temperatures a little bit lower, and then the moisture and cloud cover keeping our overnight lows a little more mild. And so we saw more of those colder daytime highs throughout July. But even though July kind of flipped the script for a few states, I also want to talk about what the year-to-dates looked like across the region. And so this is the similar map using our statewide temperature ranks, but this is using the 7-month year-to-date January through July average temperatures. And what you'll notice here is a lot of that dark orange here, especially across the eastern part of the region. And if we look at the ranks, we still have pretty much the entire Midwest here, states that are having their top 5 warmest year-to-date temperatures. That most notably includes Ohio and Michigan, who are currently have their 2nd warmest year-to-date temperatures. But Indiana, Kentucky, Illinois, Wisconsin, Missouri, Iowa, and Minnesota all still have top 5 warmest years. So it'll be interesting to watch as the rest of the year goes on and see if we can set any of the records in these states. Moving to the west, still above average, but not as extraordinary warm as in the east, but all of the states in the central region are having at least a top 25 warmest year to date on record. And so pretty impressive warmth we've seen so far throughout the year. Now, we can also look at our statewide precipitation ranks to see how we've done on rainfall in July, and a bit of the haves and the have-nots here. We look in the western part of the region and have several states with slightly below average precipitation, the most anomalous being Wyoming, ranking with their 20th driest July on record. But we also have Ohio, far to the east, who had their 21st driest July on record. But surrounding Ohio, the rest of the Midwest was very wet, excuse me, and a lot of this rainfall, some of it came from thunderstorm complexes, but also the remnants of Hurricane Beryl. And so we see Illinois, for example, recorded the 7th wettest July on record, and otherwise the surrounding states were all pretty close to top 20 or 30 wettest months on record for July. So wetter to the east, minus Ohio, and a little bit drier towards the west. But with it being July and most of our precipitation coming through thunderstorm activity and some convection, a lot of times we can see very localized precipitation patterns, and the statewide totals might not give us the best representation. So I also wanted to show the county precipitation rank, because when we look a little bit more localized, there were some all-time monthly records that were broken here. And so first, some wettest Julys on record. If you look really towards the center of your screen, it's kind of tough to see the state lines, but you can see an area of the dark blue showing counties that have received their wettest July on record. And this is essentially the surrounding counties around the St. Louis metro. Was very wet in July, and so several of those counties on the Missouri and Illinois side of the Mississippi River did set that record. Another one is up in central Michigan. We had one county that recorded their wettest July on record. And then if we look way up to the Canada border in far northwest, North Dakota, they actually had their driest July on record there. And so a few records, but overall still not a lot of extremes here in July. So moving forward a little bit and shifting to looking towards the past 30 days, that's going to cover the second half of July and the first 2 weeks of August here. I'll start by showing this precipitation map that's just showing totals across the region. And we see a lot of red on this map initially. So looking into the western part of the region, any of those solid red colors or the dark red are locations that have received less than an inch, and most of that's confined up to the northwest and the Dakotas and Wyoming and Montana. But we also see a lot of kind of the darker oranges spreading east, and that's locations that have seen less than 2 inches of rainfall over the past 30 days. Really the only spots that have picked up some locally higher totals getting into the 4 to 6 plus inch range is kind of central Minnesota, and then moving from southeast Iowa through Illinois and into Kentucky. The rest of us have seen much less rainfall. And so if we take these totals here and put them a little bit more into perspective with what we expect in different locations for this time of year, we can look at our percent of normal precipitation for the last 30 days as well. And so what you can see here is a really mixed bag out in the west, but certainly a dry signal for a lot of the central part of the region. So from the Dakotas down through Nebraska, Kansas, and Missouri, even southwest Iowa, have been much drier than usual over the past 30 days, and also into Indiana and Ohio. And so after seeing plenty of rain throughout the spring and early summer, some of these locations are starting to dry out here. To come along with that, we've really continued our pattern for the most part with temperatures as we've gone into August. And so here we can see our departure from normal temperatures over the last 30 days, pretty similar to what we saw for the July rankings as well. We still have this core of below average temperatures kind of over most of the central part of the region here, a little warmer over to the east and in Ohio and eastern Kentucky, and then warmer over to our west, but still seeing a lot of below average temperatures for this time of year. And it's pretty remarkable because usually from mid-July to mid-August, we're going to see our climatologically highest temperatures of the year. So having these below average temperatures is welcome for many here. And just to illustrate, I wanted to show here, this is the highest one-day maximum temperature over the past 30 days. So what was the highest temperature recorded? And a lot of us, especially more towards the east, have really just not seen some of those late summertime temperatures that we might associate with some extreme heat. And so, for example, here where you see these blues up in Minnesota and Wisconsin and Michigan, these are locations that have not touched 90 degrees over the past 30 days. Certainly rare for this time of year. And in Wisconsin, for example, we also see some of this teal mixed in, but their statewide high temperature so far in August, only 94 degrees. Even farther south and west, where we've been a little bit warmer, notice here that this kind of yellow line is 100 degrees or above. And it's pretty remarkable that states like Missouri, Illinois, Kentucky, Indiana, and Ohio haven't even gotten close to that 100-degree mark during this time of year. So looks like plenty of heat still out to the west and western Kansas, Nebraska, and the Dakotas, but not much of that summertime heat to the east. Another thing we've seen with these below normal temperatures are actually some 30s getting up into the Dakotas over the past week. And so it may feel a little strange in August, but maybe by the next webinar, we might actually be thinking about that first fall freeze or the first night when the overnight low temperature falls below 32 degrees Fahrenheit. And so I did want to share this tool. It's not a forecast for that first freeze, but it's looking at the climatology of low temperatures across each of these counties and calculating the median date that that first fall freeze occurred on. And so we can see here the for this part of the region that doesn't include some of the west, we can see Iron County, Michigan was actually our first to pop up here on the freeze tool with the first date of September 14th. So that would be before the next webinar. But you can see this kind of dark purple over the upper Great Lakes and upper Midwest here. These are typically the earlier frost dates, and then we see more of the blues as you get down into Kansas, Missouri, getting into the lower Ohio Valley. And these are going to be locations where we typically see that first fall freeze more into October. So still have some time in some locations, but we could definitely see a freeze in some spots before the next webinar. And so now that we've looked a little bit at precipitation and temperature, how have these trends, and especially some of the dryness over the past 30 days, resulted with our soil moisture here as well? And how does that soil moisture impact drought? And so I'll start by showing our Climate Prediction Center soil moisture models here on the left. On the top left is just a soil moisture ranking percentile. And so this percentile is just going to tell you for that given location and that given day, how does your current soil moisture compare toward the historical record at that location. And so those warm colors are going to be dry soils, low percentiles. The green colors are going to be wetter soils with more water content there. And so we can definitely see a mixed bag across the central region. Moving from west to east, we have low soil moisture in Montana, Wyoming, northern Colorado, and North Dakota. Some spotty dry soils in Kansas over into Missouri, and then very dry soils in Ohio. Elsewhere across really the northern Great Lakes and upper Midwest, still some wet soils, especially in Minnesota, from some of that early summer rainfall that was causing a lot of flooding just a few months ago. But if you look on the bottom left, we can also look at the change we've seen over the past 15 days. And we do see, wherever you see these warm colors, that's showing soils that are losing water content, and we are seeing those warmer colors in drying soils. Some locations that are getting wetter, but definitely drying out, especially in Nebraska, Iowa, and Missouri here. We can kind of confirm this model by looking at our U.S. Department of Agriculture NASS statistics on the right. And this is just the survey for topsoil moisture. And this is showing the percent that's short to very short and would show some dry soils. And so the top number you see for each state is the percent of that topsoil that's short to very short. And we do see, especially farther west into the region, some states that have a lot of topsoil moisture that's dry here. And so Montana and Wyoming really stick out, but really the Great Plains states are all 30 to 40 or 50% in Kansas with that short topsoil. A little bit better to the east, but of course, Ohio having some difficulties and Indiana a bit dry as well. And so can definitely find some dry soils this time of year. And so with this soil moisture data, it's no surprise that the drought monitor is looking a lot like some of the soil moisture models here and depicting that dryness. And so this is the current U.S. drought monitor map that was released earlier this morning. And we can see, again, a mix of conditions around the region. And so the areas we've been talking about that have been hotter and then also drier for a longer time, we've got drought in Montana, Wyoming, and Colorado. Western Montana, where drought's been lingering for some time. If we see this dark red, that's the exceptional drought or D4 category. That's the worst category for drought, but also a pretty expansive area of D3 extreme and D2 severe drought as well. Some other kind of highlights here in Boulder in Colorado, you can see a small red dot. The city of Boulder saw their driest May through July on record. And so we see that D3 or severe drought here, and tough to see on this map, but actually a little bit of D3 in Southeast Ohio along the West Virginia border as well. First D3 in Ohio since 2012, when we know we had very widespread drought conditions across the state. But even out of these extreme areas, still seeing a lot of drought or severe drought in the Western Dakotas, Kansas, and into Missouri, and of course some lingering concerns here in Ohio as that drought continues. But if we look at our 4-week change, and so this map is going to show what our drought categories look like compared to midway through July on July 16th, the warm colors are going to show degradations or increases in drought severity, drought category severities. And then the green colors are going to show where there are improvements. And I think one immediate takeaway is a lot more of the yellow on this map than green. Certainly a few spots that have seen some improvement, especially in eastern Kentucky and parts of Ohio. But then we see a lot of this degradation in Kansas and Missouri, and again here on the western Great Plains. So some locations are starting to dry out according to the drought monitor and those precipitation deficits as well. But overall, it's interesting to think about where we are today compared to last August. And so this is our U.S. Drought Monitor class change looking back to August 15th of 2023. And most of the region has done a complete flip-flop. So here we can see that we've had some degradation since last summer across the western part of the region that was doing a lot better last fall. And then looking across the Midwest, almost everywhere is doing better than they were. So a lot wetter across the Midwest than those drought conditions last fall. And Ohio was actually doing okay last fall and has that drought. And so a lot of locations have flipped from a wet year to a dry year, or vice versa, as we can kind of see with this map here. So pretty interesting across the region. And so we've talked about soil moisture and drought. What about some of the current hydrologic conditions across the region? Well, they're not as exciting as late spring or early summer, when we had a lot of river flooding and on major rivers as well. If we look here, this is showing all of the stream and river gauges across the region, and the color coding shows whether if you see the warm colors, they would be in a flood stage, either minor, moderate, or major, or if you see a brown dot, that's a low water threshold. But most of the gauges we see are green across the entire region. Not a lot of flooding. We see a few areas here, but I know, for example, in Missouri, some of this is just response to very recent heavy rainfall. So overall, no widespread flooding concerns at this time. But if we look at 28-day stream flow that goes back over the past month, and look at it more on a basin scale here across the region, still kind of seeing a mixture of conditions, just like with some of the other indicators of precipitation and soil moisture. And so here we can see stream flow, excuse me, really responding to the drought conditions in Kansas. A lot of basins here that are showing below normal or much below normal stream flow, similar to find these in the Western Great Plains and up into Montana and Wyoming as well. We see the stream flow drought response here in Ohio, but I also want to point out that we still have across a lot of the Midwest here, a lot of locations with above normal and even much above normal 28-day stream flow still, as they're kind of drying out from all the earlier season wetness we saw there. And so moving forward, what are some things we might look for here? On the right, this is a graph that's showing the stage height, the river stage height at the Cairo gauge on the Ohio River. And we see the pink line, which is 2024 here. And then we see the green and blue lines, which show 2023 and 2022. And then we have a long period of record at this gauge back to 1858. So we see a few bands here. The kind of tan gray band is what's normal conditions. And then the blue band is the absolute highest and lowest stage we've seen for that day of the year. And so you can see we're really heading towards the fall, which is climatologically our kind of stream flow low anyways. Seasonally, that's when the rivers are running at their lowest. And at least here on the Ohio River, where we've had drought within the basin, really sitting as of mid-August right around average. But we'll point out, as many know, in 2022 and 2023, we had some below average stream flow. So just to show this, and a lot of the rain we see over the next month or two will have a big impact on all of our basins here and some of that fall stream flow. And so now that we've gone a little through our current conditions, I also wanted to show some impacts and discuss them as well. I'll start out with a stunningly catastrophic photo. This is the Alexander Mountain Fire. So this is from Colorado, just west of Loveland, Colorado. One of a few fires that occurred in late July and lasted into early August. I think these are all contained now, but definitely thousands of acres that were burned, evacuations, and a lot of trouble with the fires there. And so fortunately, only in Colorado we've seen some fires, and previous years we've seen them be more widespread, but it's definitely the time of year to think about fire season as well. And so starting off to think about other impacts we've seen, drought impacts, where we're seeing drought, I'd say there's maybe three kind of areas of drought across the region right now. Farther west, drought's a little bit more established, and I've been watching since earlier in the summer, and so we certainly have a range of impacts here. And so this picture shows a dry farm pond in Harding County, South Dakota, for example, but also a lot of poor pasture and rangeland condition, also wildfire and grassland fire concerns in this area as well. The area circled here that encompasses Kansas, Nebraska, Iowa, and Missouri is really a kind of short-term emergence of drought conditions where we've seen precipitation deficits over the last month or so and are starting to see some agricultural impacts, mainly I think because it's an important growth stage of the year for some of our row crops when these dry conditions occurred, and also seeing some pasture stress there. But this is kind of an emerging drought. And then over to the right or to the east here in Ohio, still sustaining drought that's been around for most of the summer here. Pretty widespread and a large variety of agricultural impacts, most notably to pastures, not having a lot of hay supply, and livestock stress and needing water for livestock. And so we're still seeing agricultural drought impacts across the region, but they are a little bit different and are not as widespread probably as this time last year. Another drought impact that's a little bit out of agriculture, but it's actually in Wichita here. So south central Kansas, I put a star on the map shown as a severe drought here on the map, actually going into some preliminary water conservation measures. And so residential here, you can see the watering schedule for the city breaks it into 4 quadrants and dealing with some water supply issues due to drought. So another interesting impact there. But while we do have these agricultural drought impacts, we also have a big part of the region that has had pretty exceptionally good weather for crops. And we've heard that crops are doing very well from the temperatures and precipitation abundant in a lot of these areas for the season. So we also have pictures like this from St. Paul, Minnesota, where we see pretty tall corn once again, and I think you could find this in a lot of the locations that are circled in green here. And so a lot of locations that are expecting pretty high yields and having a good agricultural year. And so to get into more detail, we can look at the USDA crop progress and conditions here. And I'll start with corn. And as we were mentioning, this is the percent corn that is rated good to excellent, and where we see a lot of green across the region, that is good news because that means a lot of that corn is good to excellent. And so really seeing a lot of states with 60, 70, 80% of that corn with a good rating here. And so that's great to see. Probably the only one below 50%, yeah, it's Kansas here, but the rest are doing well on corn. On the right, we can look at our progress here, and we can look at the percent that is now going to see how that's changing across the region here. And what we see is green ahead of schedule for the season, or at least the past 5-year average for most of the southern part of the region, excluding Colorado. Up to the north in the northern Great Plains, a little bit slower with the corn there. Very similar story with soybeans. So on the left, again, conditions, a lot of good to excellent ratings, 60 and 70% across most of the region here. Looks like our lowest is 59% in Ohio, which is to be expected, and 56% in Michigan. But a similar story when we look at their progress for percent setting pods, a little bit ahead of schedule in the southern part of the region, getting into the northern Great Plains a bit behind schedule as well. So some differences in some of the crop progress, but pretty great conditions for corn and soybean ratings across the region overall. And then finally, we can also look at our pasture and range conditions and look at the percent that's good to excellent here. A little bit more variable, but still seeing a lot of good pasture conditions. Some of the worst, though, we do see Montana and Wyoming, obviously, but Kansas and Nebraska below 50% for those pasture and range conditions, and Ohio at 35%. But another thing I want to point out, and included a couple pictures here, states like Missouri, we may have a pretty good overall rating for the pasture and range conditions, but we are seeing, if you look at the bottom number, changes from the last week. And when we see a -6 or a -4, we're losing percentage points of those pasture ranges that were considered good to excellent. And so are receiving reports in this part in eastern Kansas and western Missouri of some dry pastures and conditions changing there. So we'll have to see how this changes as well. We did have some notable severe weather. Here's a fun one from July 31st in Minnesota. Largest hailstone reported in the state since 1986. And so we can actually see in the picture measuring right at a 6-inch diameter. So pretty amazing picture. That July 31st day was a pretty widespread severe weather day across most of the region. So we can look at our Storm Prediction Center maps, see these wind reports in blue, a few tornado reports in red, and hail in green. But really one of the hardest hit areas that day was eastern Nebraska, where you see a cluster of storms here. A lot of power outages, so around 400,000 power outages in eastern Nebraska. The worst was in Omaha, where the city set a record for their largest power outage, and I know it was an extended time for some folks to get power back there. Another kind of power outage severe storm system we had moved through was right at a week later. This one really focused on Northeast Ohio and the Cleveland area, damaging winds and tornadoes here. Left behind 400 to 500,000 outages. And I know at some point the Debbie was also impacting Southeast US, and there were more outages from this severe weather event than the impacts of Debbie as well. So a few impactful events. And while we weren't extremely ahead of average over the past month for that severe weather, this does kind of continue the trend that for parts of the region, we've had a very active severe weather year. And so this map shows the number of tornado counts by state, or the tornado reports. And this is tornado reports that go to the Weather Service, so there could be a duplicate. So it's not the actual number, but just shows you states like Nebraska, Iowa, Illinois, Missouri, very active year. And in fact, we have Ohio, Illinois, and Iowa that have all already broken their tornado record in 2024. And so a few other things around the region that come along with this time of year. The Great Lakes are heating up here. And so we see on the right, those blue lines show our climate average for the lake water temperatures. And you see across all the lakes, but definitely Lake Erie as well, spiking on that red line, which is our observations. And so as we reach our warmest time of the year, also a little bit above average. And so with that, we see on the left here a harmful algal bloom in western Lake Erie here. And so we can see the concentrations, but also even on a visible satellite, you can see the green there. And so we'll be watching temperatures and precipitation to see how that can impact those lakes there. And then fall fire weather potential. We looked and saw some fires in Colorado, but again, in this region, haven't had a lot of issues yet this year. Fortunately, from the National Interagency Fire Center, the forecast for September and October calls for mainly a normal wildland fire potential, which is good as we head into the fall and start to get into harvest season for some states as well. And so now that we've gone through impacts, I'll spend the remaining time here going over our outlooks of what's to come. And we'll start with our 7-day quantitative precipitation forecast. And this map shows forecasted rainfall totals over the next 7 days. And I'll start by mentioning the western half of the region, essentially a lot of green. And green means less than a ½ inch over the next week. And so some locations may be pretty dry. A little bit better to the east, where we see these blues indicating totals anywhere from a ½ inch to up to 2 inches. But areas like Kansas, Nebraska, and Iowa that could use more rainfall, according to this forecast, not seeing as much over the next week. Do notice a chance for rain in western Montana that would certainly be welcome as well. But then going into our week 2 and looking at the 8 to 14 day outlook from the Climate Prediction Center, this is essentially the forecast for the last week of August here. We see kind of a continuation on the temperatures of what we've been experiencing, maybe an eastward shift. So what we see here, the warm colors are showing a likelihood of above average temperatures, and the darker the reds, the higher the probability of those above average temperatures. And so the farther west you go in our region, the higher chance for some of those above average temperatures. But we do see, even though it's not a high probability, the tendency to lean below average for temperatures across the Ohio Valley, kind of similar to what we've seen over the last 30 days, a little bit towards the west. And then we look at our precipitation outlook, not a strong forecast here, only about a 33 to 40% chance of those below average precipitation in week 2, but still showing that it's not much of a wet signal, maybe near normal or drier than average conditions in week 2. Okay, and looking ahead a bit farther here, so this is our monthly temperature outlook for August, and very kind of similar pattern. Again, western US and western part of the central region having the strongest or highest probabilities for above average temperatures, but also notice almost the entire rest of the region has at least some probability of leaning above average for those temperatures, except for the far, pretty much Canadian border and upper Midwest here that have equal chances for either below or above average temperatures.
And that's for September. You said August, but you really meant September, didn't you?
Yes, thank you, Doug. I appreciate it. Yes, so our September outlooks that were issued here yesterday on August 15th, or today on August 15th. So our September monthly precipitation outlook still showing this dryness here into the plains, but also a little bit more confidence in the forecast as well. So looking into Kansas, Colorado, and Southwest Nebraska, 40 to 50% chance of those below average precipitation totals. And so maybe not a good forecast for September in those areas that have drought conditions already. And then I'm going to move forward to our seasonal outlook. And as I click forward here, you notice the maps don't change a lot. So now instead of looking at September, we're looking at the 3-month forecast for September, October, and November. And a very similar pattern here. Above average temperatures for now, the entire region, most towards the west. Also higher probabilities getting over into Michigan and Ohio. And then this signal for dryness over the Great Plains as well. So really expecting that pattern across most of the fall months. And as we look into our long range outlook, and so this is for winter 2024-2025, so December, January, and February, things finally start to change here. And so now we see for this forecast, not much of a lean either way in temperatures. Some maybe low probabilities for cooler temperatures to the north, same with warmer temperatures to the south. And fortunately, most of the dryness kind of suppressed to the south in this forecast as well. For our region, whether it's Montana or the Ohio Valley, prediction for above average precipitation over the winter. And so the kind of what we're seeing in these forecasts is a very classic kind of El Nino, or excuse me, a La Nina pattern for the fall and winter months. And the reason this is kind of showing up in the forecast is we are still expecting a La Nina to develop. And in fact, we're currently under a La Nina watch. ENSO neutral conditions are present. And so that means sea surface temperatures in the Pacific Ocean are actually currently right at average. When they're warmer, we have an El Nino phase. When they're cooler, we have a La Nina phase. But we are seeing those temperatures slowly cool and are expecting to see La Nina conditions develop later on. And so this figure on the right shows our percent chance of the neutral conditions, which we're seeing right now, La Nina in blue and El Nino in red. And the kind of descriptions on the bottom here are the seasons. And those seasons are just the first letter of different months. And so OND, for example, is October, November, December, and NDJ is November, December, January. And so we do see later into the fall, so October, November, December, and then a one-time step forward, around a 75% chance of this La Nina developing during this time. and then those probabilities start to decrease. And so the thought is maybe a kind of slow onset for La Nina, and then maybe a quick transition out as well. But definitely looks like we could see a La Nina during the winter, although there is a lower probability of neutral conditions as well. But just like the forecast we saw, these are what we would look at for looking at past La Nina years and seeing what kind of conditions we've seen to try and get an idea of what the future forecast might hold. And so starting with the fall here, these are La Nina conditions and the percent increase in risk for either warm extremes and warm colors or cold extremes, and wet extremes and dry extremes. And so I'll start with the temperatures, and we see for most of the central US here, especially kind of farther south in the central region, a higher increase in risk for those warm temperature extremes during the fall, and then a higher increase in risk for dry extremes that goes a little bit farther into the region to the northeast. And so if you remember those forecasts, the kind of heat and dryness to our west and southwest, this resembles a lot of some typical La Nina falls. But then when we get into a La Nina winter, that heat moves a little bit farther south, and typically it's more of the Gulf Coast and southern Great Plains. But we do see also in the northern Great Plains an actual increase in the risk for some cold extremes during La Nina as well. And then we see the increase in risk for the wet extremes from the La Nina. So La Nina may not be good for drought in the fall, but would be great for a wetter winter in some locations. But with La Nina moving in so slow and some of the uncertainty, we'll have to see for those fall outlooks. But other than that, that's all I've got for today. I'll leave you with this picture on the right. It is currently the Missouri State Fair. I know it's the state fair for other states, such as the Iowa State Fair. So hopefully the weather can cooperate if you're going out there. But then I'm just going to list a lot of contacts here, a lot of partners who really help to make these webinars happen, and some links to our Central Region headquarters and regional climate centers. And then just as a reminder, the next webinar will be September 19th with Trent Ford, Illinois State climatologist. So thanks everyone for your attention today, and we have some time for Q&A.
Yeah, all right. Thank you, Zach. And as always, send all your questions to Zach after this. Just kidding. You can send a lot of them to Zach, and he'll know who else to send them to. But any of those folks listed there know who to send them to if they don't have the answers. Let's go to the questions, since we don't have all the time in the world, but we have some good questions that we do want to address. So some of these we've already addressed, and we'll be quick with them. So Dennis, let's talk a little bit about, or Zach, let's talk a little bit about how the drier conditions in some parts of the region have been balanced by the cooler, or at least normal temperatures. Let's say that in the context of, well, we could say it in the context of energy use as well as agriculture. So let's lean on the agriculture side, since that's our strength, I guess. So either Dennis or Zach.
Go ahead and start, Zach.
Yeah, so fortunately, some of these short-term precipitation deficits have also kind of overlapped with this area of really the corn belt that's essentially been dry, and then this cool period for the past 30 days. So I think that's kind of helped us avoid what we would call flash drought, which would be those rapid precipitation deficits. You couple it with heat and really quick vegetation stress. But I think that the cooler temperatures combined with more moisture earlier in the summer has helped things hold on a little bit longer. But Dennis probably has something to add for more specifics on the agriculture.
Yeah, remember what we're talking about here when we're talking about drought specifically. We're talking about a water balance. How much water is coming to the surface because of precipitation, and how much is going away from the surface by evapotranspiration from the surface or transpiration through crops. And when you have lower temperatures, not quite as hot of temperatures, there's not as much demand from the atmosphere to extract more moisture from the soil. So even though you may have less water coming to the soil, you are losing less that's going back out to the atmosphere because of that. So it evens out that balance, and there's not as much demand on the crop, so less chance of stress on the crop.
And Dennis and Zach, it's arguably more important in June, July, and August for that to happen to avoid sort of drought stress than any other time of the year. Is that correct, especially in agriculture? I mean, that seems very.
It's very much crop based. If July is the big time for corn, more stress and an imbalance on that, and will do more impact on corn in July. Soybeans is more of an issue in August. The part of the problem so far is this dryness has been focused on pasture and rangeland. That comment was made yesterday by the state climatologist, Aaron Wilson from Ohio, that so far crops have been generally okay, but pasture and rangeland, so he's been calling it a pasture drought because they have been affected more than the row crops have.
And Dennis, let's make sure that the east-west there is an east-west connection to even pasture. Certain time of year, April, let's say April, May, in the high plains in the west, if that's dry, then we lose a lot of grass as opposed to later in the year for other.
Correct.
Ones. Yeah.
Correct. Yeah. Cool season grasses, which is more in the northern plains in the spring and early summer. You need moisture then for that to be able to grow. Mid-late season precipitation doesn't do a whole lot to promote growth.
Yeah. Thank you. Moving on, there was a great question about error correction, accounting for the number of stations over time, and the change in instrumentation I added, the change in longevity of stations in and of themselves, and even placement of these stations. And so you'll see a bunch of sort of answers to that question about what is the error correction for all of this, and how is that done from 1895 to 2024. There are a number of papers about how. So I work for the National Centers for Environmental Information. This is what they do for a living. They what we call homogenize the data set and grid it over time. And we don't have time to go into that. Plus, I wouldn't know all the details on how that's done. But all of that information is public and online. You can either search it out or email me, and I can send you more information, or at least to the right people who can explain it better than I can. And I think Dennis even had a few comments, being a state, and Zach, as state climatologist, you have to deal with this all the time.
Yeah, and I would add that most of the kind of errors you might see too is maybe missing out on some of extreme precipitation when we really didn't have the more dense rain gauge networks farther back. We know how localized precipitation can be compared to temperatures. And so usually there's a little bit more certainty with those longer term temperature records. It's always tough to capture the most extreme precipitation because it's so locally variable.
Right. And the other thing to add about precipitation is it's only the last 30 or 40 years that we've had decent radar information as well to enhance some of those values where we don't have a gauge. And you can't have a gauge at every point on the ground, right? So the radar does pick up some of that, some of the more heavier rainfall events.
But the graphics that we showed here, I don't think incorporate the radar data. We can capture that by looking at some of the radar data, but these graphics, I don't think incorporate that. They just incorporate the surface-based measurements.
Yeah, there is a site out there that does, and that's with the Weather Service. They do provide a blend of surface and radar depictions. Nothing's perfect, but it gives you a different view, and you can sometimes see what those are. Moving on, is there any connection between wildfire and drought in Colorado? It's a very Yeah, yes. The answer is obviously yes. But there's a lot more to that discussion. I tried to get at some of that. Wildfires can happen every summer in Colorado and in the West when things dry out, and inevitably they do. It can be exacerbated by drought and other things like heavy fuel loads, which means a lot of undergrowth and things like that that have built up over the years, especially wet years, as a matter of fact. Wet years lead to a lot more fuel for those fires. And beetle kill and other things that affect forests can also lead to more wildfires. So drought, yes, but not necessarily. How about that for an answer? Anything else you guys want to add to that? Okay. Dennis, if you can help, I guess you did help a little bit by putting a website in there. Talk a little bit about CPC soil moisture calculations.
Yeah, I did a quick look and put that link in there. It's called the leaky bucket model because basically they're doing a gross assessment of what I talked about with drought earlier. How much rainfall is falling into an area, how much maybe is running off, how much then is being evaporated or transpired back into the atmosphere, and then on a fairly gross scale, contouring that. Generally, it's pretty good, and I think the question dealt with time of year, and I was not clear on the write-up that it's time of year, but I'm pretty sure it is time of year based, like most of our products are. So you're not comparing now versus March. You're comparing now versus now in previous years.
Yeah, which makes sense. Eleanor mentioned that the fires in northern Colorado are mostly contained. I wouldn't say they're necessarily out, but they're mostly contained. I think that's not an issue at the moment. Someone asked where they can access long-term climatic data. I'll just say this person wanted it for Colorado. You can access it from those places that I mentioned there. The National Centers for Environmental Information has it all, but we also say that the state climate offices almost always do too. And so in Colorado, you're lucky because they have a pretty strong state climate office. And if you talk to them, they can probably help you out, depending on which variables you'd like. And then I guess someone who has left, but they asked about how do you understand, what data are used to understand pasture range and corn and soy conditions? And Dennis, you probably want to say this again.
Right. There are not actual measurements of sensors of any kind. These are all based on human observers who are trained to, and I think they maybe have a cycle of an area that they look at to look at different conditions, and then they assess generally based on what they see, and that's averaged over the state. So that's why you kind of have to kind of take it. Generally, it's pretty good, but because you're compiling a whole state into one number, it does throw things off a little bit because we know things can vary even across a county, but definitely across a state as to where things are better or worse than others. One thing I am going to do from a crop progress standpoint that we didn't talk about, because there's been a lot of variability in the way of corn development, I'm going to put on a website that people can check corn growing degree days development, where they are based on when they planted and how conditions have been around them. So go ahead.
Yeah, and Dennis, do you want to say why that happened?
Because of the wetness in the spring, there was delayed planting in different areas, some replants. So you have things planted at different times. The power of this tool is you can pick your location, you can pick your season length variety, and it can show you how many degree days it's accumulated and where you're likely going to be before we get to freeze in the fall.
Okay, so the next question is, what are the important parameters or indicators that can help indicate potential occurrence of drought? That is a very long answer, and it depends on where there's a lot of depends on that. And Zach, I don't know if did you put on the seasonal outlook for drought anywhere?
I didn't include the seasonal outlook.
Can you bring it up? Can you just bring it up? Because I just want, did you pull it up just off the web?
I can do that.
Because I want the person who asked this question to know that we do have an outlook, and everybody else, we do have an outlook for drought, and we normally include that. Zach got off easy today. I didn't remember that. So
Can you see my web screen now?
Yeah, I see it. Can you blow it up, click on it or whatever? Seasonal, yeah. The seasonal one.
Sounds good.
Not the monthly. Yeah, there you go. Yeah.
Oops.
Yeah.
Got it.
Point out there. Okay, there's the seasonal outlook for drought. There's a lot of things they take into account when trying to decide where drought may occur. And it does sound like you did mention the word, you said potential occurrence. So I assume you're looking into the future a little bit. Other indicator, and so this is driven by La Nina, El Nino, neutral conditions, whatever. We call it ENSO. So that can drive it, as well as normal seasonal, I would say, conditions can drive it to some degree as well. Antecedent conditions are a big deal. So as Dennis said, how much did it rain or snow or whatever? Those all matter. But it's a long discussion that we probably can't get into today. You can contact any of us, and we can do a little bit more on that. Quick question here, or not so quick, but I've heard of exponential changes in climate that will be coming in the next few years because we have never seen climate catastrophes in the recorded history. What is the worst case scenario? Will the planet have humans on it in 20 years? You know, I always want to go back to George Carlin on this one because he always says, don't worry about the climate. Nothing. It's going to take care of itself. It's the humans the humans are going to be gone. So instead of telling that joke, I'll simply say that we have seen an increase in extreme events, and you can call them climate catastrophes. You can call them what you want, but I don't think I'm going to jump into sensationalizing the fact that we're all going to die in the next 20 years, because I don't think that's going to happen. There'll be impacts, yes. But again, a long question, better for a climate change, maybe topic or webinar in the future. And feel free to contact me if you want more information on that. Perfectly fine. Are the ENSO risk maps based on the entire? No, they're not, Jennifer. Are the ENSO risk maps based on the entire record of past La Ninas or some other periods of the last 30 years? So they haven't been updated lately. And Zach, do you remember when they started? I think 1950, maybe?
I know they started in 1950. I'm not sure the last year they grabbed, though, on the other end.
I think 2015. So they get updated occasionally. I'll say that. Yes, there have been changes perhaps to the way La Nina and El Nino impact North America, right? So it's a good question, and this is the best we have at the moment in terms of extreme impacts. Oh, and then a thanks. So that wraps it up. It's 2:01. I hate to keep you guys any later than I have to, especially my speakers and participants who have volunteered their time as well. So I'm going to say, Zach.
Doug?
Yes.
Doug?
Yes.
Tell them to hold on just 1 second. Okay. I put another website into the ENSO risk map question that is updated more currently. It's not the extremes risk, but it's another composite of what happens during parts of El Nino, La Nina events. Check that one out.
All right. Okay. Yeah. And if you have any questions about that, feel free to contact Dennis or me or Zach, and we'll get back to you again. So I'm going to wrap it up here. We'll see you on September 19th, where we have the Illinois State Climatologist on board doing the same thing Zach did. So thanks, everybody. Good month to you.